logic will work and load the data into the execution stage. We can see here the first cycle is 1, and then when the store happens, and 1 cycle later the data changes to 17, and it compares with the data of number 2 register file. It's 16, and then it will get the result and drive the flash to be high. So here we have 3 types of data hazard. One is the data load is needed by the instruction after it, and then the bypass happens to load the data into its next instruction. Then the instruction is active, and it drives the flash to high. Then the instruction after this branch instruction is erased, and then after a while the new data is loaded in. Okay, so the next is step 3 of our demo. It's called change your input data, your cache miss rate, and run simple state again. How many cycles did it take? So right now our miss rate is set to 1, and our penalty is set to 1. So let's run this to 6 microseconds, because it will finish compare all the data in because in our data file we have an array of 32 data, so it will compare and get the minimum and maximum value of our 32 data. Okay, this time I loaded the memory stage because data memory is in this stage, and it saves the data that compared. We can see on address 112 and 106. 112 saved the address of the minimum data in this array. The 106 saved the maximum, the address for the maximum data in this array. And since we only have 32 data saved from address 200 and to 231, so 232 is initialized to 0. So we can use this as a benchmark, because our 0 must smaller than other values in the array. So first let's check whether it is stored the correct data. Let's go to the address 200 to 231 and change their play. We can see position 209 saved the number 1, and position 223 saved the number 32, which is obviously correct. So the next, let's go to the cloud counter and see the performance right now. So it shows the cycles number will be the cloud counter shows its cycle stops at the 527. This is for the penalty equal to 1 and miss rate equal to 1. Then we change the miss rate, for example, equal to 5, and keep penalty equal to 1. Then we compile the files. load the memory stage and also load the clock counter in the top CPU module. Then we run it, check where is our 232, which store which is here. Let's check our clock counter. So this time we can see the clock counter when the program finished, it points to 560, which is larger than the 524 with the first time. And because the miss rate goes high, it changes from 1 to 5, which causes the clock penalty of this in this situation. Then the next is change the input data and see whether it can work in the in our tester program. Then I go to the folder of the project and then change the data. For example, let's copy paste this data and put them into another position. Then we reload the program. Then we go to the two positions. We can see here this time the number has changed because the data saved in different places. Which here the minimum value point to 217, which saved the number 1, and the 223 still saved 32. So, which means changing data, our test program also runs well. And then we checked the clock counter to see whether is there any influence on the clock. So we can you can see here it stays the same. So changing the data doesn't